So we usually start these interviews with, take us back and talk about your early influences, but we're going to change direction on this one. I want to start with some things that went on in your life with this organization, because I think it's very special. You were the founding editor of Interface in 1992. You became the editor of the Journal of the Electrochemical Society from '96 to 2007. Which was a major transition period that we're going to talk about. You were the founding editor of Electrochemical and Solid-State Letters. And of course, you were president in 2014. And my producer even forgot to note something that I think probably pushed you into the fray in the first place. It was a very significant role in when we changed the editor-in-chief of the journal in I think it's 1990, and you were involved in that transition as well. And that was significant because the editor was Norman Hackerman, had been there for 40 years. Right. And so, we're gonna back you up before 1992 and say, you got into in a big way these activities probably around '89, let's say, and so you joined in 1975.
Right.
Did you have a feeling that you were going to play this kind of significant role in the organization when it all started?
No, I had no real plans or really thought through anything like this. All I really knew in 1975 is that I very much liked electrochemistry topics, and I was in graduate school at the University of Texas, and really just trying to discover what my life would be like, what I wanted to do for my life, but I certainly had no idea that I would have any opportunity like this to play a significant role in the society. Mm-hmm. But it really, I think, came about kind of one step after another. Just becoming involved in, say, the publications committee in the 1980s. Then I was asked to head the search committee, actually, for who turned out to be the editor after Norman Hackerman. It was Barry Miller. Mm-hmm. And I remember working with the chairman of the publications committee on exactly how to do it. Because
who was that?
It was Lee Hunt.
Okay, yeah.
Lee Hunt, and because we hadn't had a search for an editor since the 1950 or so, yeah. when Hackerman took over, and so we didn't know how to do it, and so it was really just a stepwise process, and one thing led to another.
Mm-hmm. Who got you? Who pushed you in from? So you were with Bell Laboratories, and we're going to be talking about that because they had such an influential role, particularly the time when you were first getting involved. Was there somebody at Bell Labs that said, "Let's put Paul on the publications committee"?
No, and I believe, well, Barry Miller could have. Barry Miller was very active, and Paul Milner, mm-hmm. but Larry Faulkner was also mm-hmm. very active.
Oh, right. Yeah.
So I think Larry and Paul Milner, Barry Miller, and a few others, but I would say those three mm-hmm. were the ones who made suggestions at the time, mm-hmm. and I suspect Larry Faulkner was mm-hmm. The principal person that first got me involved in some of the activities.
And what a job it was. I kind of think, not to make a joke of it, but nobody wanted that job. So you was a new guy, and you got tagged with, replacing a legend. A system, right. An era. It was. I was involved with the society at the time too, and the difficulty that we were facing, because we were changing the entire editorial system, right. Because Norman Hackerman was such a driving force and led it in a certain way for so long. We actually had an editorial office at his university, Rice University, where he was the president, and we were just changing the whole system and actually taking advantage of some of the new technologies. We hoped to, all this was in the background, and so like what a job. And so it feels like they almost gave it to the new guy because no one else wanted it.
Maybe.
Well, and I mean, did you find that challenging? How do you? I mean, there are a lot of good people that helped. There was a whole search committee, but was that something that was particularly, like how do you organize to do something like that?
I was very involved in the publications area, in the publications committee, and I was one of the divisional editors at the time. And I guess I just worked well with Lee Hunt and the other members of the publication committee, and he asked me if I would do it, and I told him that I was sure I could get it done, that one way or another we could get this done. And so we had some confidence in each other. And Lee actually did a lot of the work also. We would talk often on the phone about what to do now, what to do next, and so forth. So it was really just a good working relationship, I think, that together we got this done. We formed a committee, and there was no established process for going through this. We didn't know quite how to do it, so we would often talk on the phone about, should we try this, try that, and we took various surveys and asked different people. So I think we just felt our way through this, and we were all comfortable with each other, and we kept the board involved through the publication committee. So I think it was just a good working relationship that we had a nice team doing this. That's what it was.
Well, it worked. I mean, the effectiveness of inserting Barry and changing from a divisional letter system to the system that we now are using, much smaller group, specialized areas. It really was almost flawless. When we made the change, so the thought you put into it and the people you selected to move it forward, it really worked.
Right. There's no doubt Barry Miller was the right person at the right time. He was so involved, and he knew so much about electrochemistry, the society, and extremely dedicated person that he was just the right person to step in. And I remember how many times he would come over to Pennington from Murray Hill, New Jersey. He was there, I think, every week.
Just about.
He would come over on Fridays, I think, was his day over there.
Right.
So he was just a perfect fit for that, and did a marvelous job. He really got this thing going in the right direction.
Yeah, so that was maybe for you step one, because shortly after, Interface came calling. There was some connection because through the transition we were looking at what we were publishing in what at the time we were calling the C pages, and I think there was a consensus that we wanted to keep the journals just strictly technical content, and we also had this feeling, and correctly because it's worked, that there's much more we can do that are not just peer review articles, and so we talked about launching a new magazine, which we did, and you got picked again.
Yeah.
And so what was your feeling about that?
Well, I was very excited to do it. I'd never done anything like that, and I remember looking at different models for how we would put this together. And again, we had a nice team of people doing this. You were a very big part of this, as well as we had some consultants on the outside. Mary Yes was a consultant at that time. And there was a nice group of people, and we talked about different models. And you mentioned the issue of technical content in this. And right away we agreed that this should not compete with the journal in any way. It should publish technical things, but they shouldn't be technical papers like you would find in a journal, reviews or original papers. They should be overview papers and wider interest papers. And it was actually a lot of fun going through the different topics and sections that we put into this interface. If you remember, we came up with a lot of ideas in the Pennington corner, for example, which you still write continuously, and a critical part was the divisional model. Every issue we would highlight a division. I think Carrie Hansen came up with that idea. So it was a engaging, fun, energetic group, and it worked. I think the publication now is really terrific.
It sure did. I enjoyed it as much as you, maybe more, because I think we were able to do so many new and good things, you know, to share what ECS was doing, to do a better job of talking about our divisional areas, you know, and these are things that are now pillars in the magazine, and we continue to do them, and we you know, it just seems to feel like it's almost getting better and better. So you're right, it was really an enjoyable time, and led to now continuing success of a new magazine. Then, next step, you picked up the torch from Barry Miller, and while he got us through the editorial changes, you now were faced with the changes in publishing as digital transition, submission to digital distribution. It was all coming, and we knew it because in '96 when you took over, that was the first year we actually started abstract submission digitally, and we just knew, you know, that it was easier and it was a step one, but that, you know, we'd be able to integrate submission through peer review to ultimately dissemination. And so I don't know what you were thinking at the time, but it was this, you know, here it was coming, and now you were taking on yet this other enormous challenge because of the change we were going to be confronted in that period, which, you know, you did it through 2007. What was that like?
At first it was very engaging. The fact of becoming an editor of a journal like this, I was, you know, very honored to do it, and enthusiastic about it. I was very enthusiastic about it. It's a big responsibility, especially at that time, because going from Hackerman to Barry Miller, and the process we had was, of course, an all-paper process. So it was more than just handling the editorials, the technical side of it, but it was also overseeing this production side, or at least engaging with the production people, because there was so much paper involved. And we had transitioned from Norman Hackerman holding paper in his office, which was the traditional way an editor would run. You would establish the paper files in the editor's office to a paper files in Pennington. So just grasping, getting your arms around this was not a trivial thing, because I had to go to Pennington to actually see the files and such. Right. You know, it was quite an event to go, and Barry was close by and I was no longer close by.
Right.
So it was a little bit more effort to fully engage the process, but I was very honored to do this, and I'm happy it worked out.
Well, it's, you know, and the commitment that you had to make for, you know, that period of time is you know, it was a major undertaking, and you got us to the other side, because by the time you concluded, we were not even talking about paper anymore. I think the last time we distributed, you know, the journal fully to our member, the paper version, was around, I think, 2004, and then we offered options and slowly transitioned away from that. And in 2007, you left the position, so you really got us home on that piece of us.
Well, I remember it was working with particularly you and Mary Yes on this, and Paul Cooper at the time was very involved. It was exciting, but also very scary, because you could see what the future held. And the future for a small publisher was a scary business, and it still is, I think. And it was easy to see how the electronic workflow and electronic distribution would favor large commercial publishers more than smaller ones. And so I think the transition made it more difficult for small publishers because we couldn't afford our own software.
Right.
We had to try and tap into others who had developed these methods, where a large publisher could establish the rules for themselves and they could afford to pave their own path through it.
Yeah.
So you could almost see the future coming, that electronic workflow and electronic distribution would make it harder for an independent small publisher, a society-based publisher,
Right.
which I think I wish many more people would support it in a bigger way. I think it's the right way to do this. The scientific enterprise is better in the hands of small, well, not small, small and large professional societies. I think that they are better stewards of the knowledge and the process than commercial publishers are.
And I think that's the reason we've, dug our heels in and been adamant about our commitment to serving this role. And you hit the nail on the head. While you were, by the time you were finished in the editor's role, we had a digital process, but the things you mentioned, like, and now we're moving to just the issue of discoverability of that content and accessibility and ability to disseminate. And, these are technological applications, marketing that, lends itself to the bigger player in the industry, and still are challenges. The submission software, all along the way, we're at a disadvantage because of essentially the upfront costs and maintenance of a system like this. Things are changing to somewhat favor us in that there's a greater demand for more openness, right? And that's creating partners who want to help facilitate what we do. But it's very challenging, and we've come a long way, but it still remains a challenge for ECS. And the final piece, and I connected to all of it, was we launched a letters publication during your service. So you were really one of the key people, but the concept came from a strategic planning committee within ECS, and so you grabbed hold of it, recognizing the importance. Do you want to comment about where you thought that fit into all of this? Yes,
there was no letters journal for electrochemistry. In physics and other disciplines, in electronics area, there's always been letters journal for very important topics, small, quick publications. And speed to publication was an important aspect to a letters journal at that time, because a full-length publication still took longer than one wanted. So it was a easy concept for people to grasp, and we were the first to come out with a letters journal for electrochemistry and solid state, but mostly for the electrochemistry side. We were the first in that area. So it was easy to engage people in this. And I was thrilled that the society had the courage to go through with this, to take this step, because it was a risk. It was expensive, and another process had to be put in place. So again, I think we had a great team. You were a champion of this right from the start, as well as the publications committee. So it was a fun process to go through, to try and develop this and figure it out. It was a good it was a good task to figure it out.
And very healthy for the organization too, because we were entering a period of time, we're still in it, where things had to evolve. You had to consider what the best opportunities were for your authors and what your readership was looking for. And this pushed us, you know, from basically the mentality of a single journal where we can capture it all. I mean, Interface did that in a different way, but I think this was a very important step that we could make that decision and started moving on that. Well, maybe this would be a good break point to, you know, start at the beginning again, because we want to talk a little bit about you, and we want to talk a lot about you, actually. And so, you know, go back to Buffalo, where you were brought up, and what got you into science? What got you going to where you are?
Well, I would say I grew up in a poor section of Buffalo. I had four brothers and sisters, so there were 5 of us, and I went to a Catholic grammar school and high school, and it was probably in high school when the right teacher at the right time, and I always liked building things. I always liked making things. Making a new journal fit right into that. And so I think it was just the spark of the right teacher at the right time showing some interest, and it just felt right. I just kind of fell into it.
What subject?
Never really.
You said the right teacher, and of what subject?
Oh, in chemistry.
Chemistry.
In chemistry. I think some of my other instructors at the time maybe weren't the best or the most engaging, and maybe this is the one that, you know, finally I clicked with the most on why I wound up in chemistry, like in chemistry more than, say, biology or physics or something. But it was really the right instructor. He was a priest, actually. His name was Father Green, and I can still picture him and just remember so many things he did. It just was at the right time, and I regret not going back more often and seeing him. You know.
Well, that is important. It's funny too. You say that you know, you had this inclination to build things, and we've done a few of these others. Some of your colleagues, when they talk about that high school influence, and it comes from the chemistry area, you know, they usually talk about they like to blow things up. We've heard that a few times. So I don't know if you're doing any of that, but I think it's a better story if you like to build things. And so from Buffalo, you end up in West Virginia, Bethany.
Right.
That's a long way from Buffalo. How did you decide West Virginia and Bethany College?
Yeah, it's interesting when you ask people. It's fun to ask people how they wound up where they are. And thinking back, it was a very troubling time in the United States at that time. This was the late 1960s, 1968 or so, 1969. And the United States at that time was more divided than any other time in its history except the Civil War, I think. And being a teenager at that time, I remember being very confused because I had grown up loving my country, respecting the leaders, especially the president and senators and congressmen. And then came this period where there was open rebellion against the government, and claims that the government was lying to us and various things. It was revolved around the Vietnam War, of course. And I remember being very confused because I very much agreed with this anti-war movement, and it really was a large movement, yet felt very loyal to the United States. And so I wanted to join that effort, but felt this sense of loyalty. And so at the time, large universities were the home of rebellion in some cases, for student rebellions and so forth. And I felt very conflicted with joining that because I love my country and I didn't like rebelling against it. And so I wanted to go to a small school.
Okay.
And my best friend and I, we found a small school. I needed a scholarship. I couldn't pay for it myself. And so I found a small school, and it was a good liberal arts school.
Right.
Kind of set in a little town in West Virginia, and just happened to wind up there on a scholarship.
Was your best friend? So your best friend went there too?
Yes, we went together.
Oh, was it a classmate in chemistry? Same interests?
He was a classmate in sports mostly.
Oh, okay, good.
More sports. We both played sports and got along, and off academic subjects, but. And so we went together, and we would go back and forth together, and room together and such. So it was kind of a easy transition.
And at Bethany, were there instructors, a mentor that got you to the next step, which is University of Texas, where we're going to talk about next?
Yeah, very much so. It was a very small school. It had about 1,000 people in it, and kind of a one-horse town. And the science departments were small. In chemistry, I had 3 chemistry majors in my class. And I wanted to just take more classes, and so they actually made some classes and where I was the only one in them. So it was just a one person, because they had a few instructors who wanted to broaden the program.
Great education.
Yeah, it was a one-on-one in some cases, and the most I had was 3 in my class, and so it was just ideal for learning and getting to know instructors. And I remember doing the labs, and they had labs in chemistry set up, the prescribed thing, and we could go in anytime we wanted to do them. There weren't set hours because there were only 3 of us, and they would just let us go in and do the labs. And in one class, I had finished all the labs halfway through the semester. And I went to them and said, I did all the labs, and they said, oh, well, we'll make some more. And so I came back the next week, and they had a few more written out. And I just would go in there in the afternoons and work in the chemistry lab, just doing these experiments by myself.
With such a great experience with the very small chemistry department, the intimacy and the connection to the instructor probably got you thinking about continuing in graduate school, beyond pretty early in your career.
Yes, I got to know the 3 instructors. We had principally 3 instructors in chemistry, and got to know them pretty well. And I had talked to them about medical school or graduate school. And 2 of them had come from Texas, and so they gave me advice, but it was really quite early on. And it really meant a lot to me, the fact that someone would actually suggest I could do this. And I think it's something that I've tried to remember since then, that oftentimes when you're a teenager and going through this, you really don't know exactly what to do next. And so someone who can observe you from the outside and make a suggestion is very powerful, I think, especially when you're unsure of exactly what you can do and what you should be planning on. And so I very much appreciate those 3 people who were just very generous with their time and took a lot of personal interest in the students.
Well, and I think that was an important point you just shared. Now that we do this Masters series, and now that you're the Masters, what we hear every time is that there were great mentors along the way to help you, and you share your accomplishments on that. But it's important to understand that was was launched. It was mentored through a lot of, in some cases, maybe it's one key person. In other cases, you know, it's just a collective of people along the way, but it's a common thread in all of them. And so you from Bethany directly to University of Texas?
Yes. Yes.
There's another great mentor.
Yeah, right.
Tell us about that.
So I was fortunate to get into the University of Texas, and I went sight unseen. Today's students visit the schools they think they want to go to, but in those days you generally pick things sight unseen. And I had enough interest in electrochemistry that I immediately zeroed in on this field, and had known other professionals in the area, particularly from Bell Labs even at that time, because the woman I married, my wife Betsy, she grew up down the street from Bell Labs in Murray Hill, New Jersey. She lived in Summit, New Jersey, and so some of the people I got to know in New Jersey were for Bell Labs people, and so I had an interest in the topic already. And so I was very, very fortunate that Dr. Bard, as we always call him, Alan Bard, that I was able to work in his laboratory.
Tell us more about that experience.
Oh, that was just terrific. There was a large group we had, and there were just so many things to learn and do. And the topic I had involved semiconductor electrodes, and solar energy conversion. And so it was a very timely topic at the time. This was the time of the oil crisis and oil shortage, and so renewable energy was a new topic, well, once again a new topic.
Yeah.
And so there was this world of semiconductors and this world of electrochemistry, and it was so many good people around, postdocs, other graduate students, and other faculty at Texas, that there was almost nothing else you wanted to do. It was just, you spent time in the lab, and we just tried so many new things. It was just kind of a joy to be there, because you could build things, try out ideas. So it was a tremendous learning ground.
You're part of a great family tree from U Texas and Alan Bard. Anybody of note in our organization that was there with you during your years at University of Texas?
Larry Faulkner had recently left.
Okay.
You know, he had there, and Joe Malloy, who ECS member, was recently there. The people there, many of them that I was with, went to Texas Instruments for their whole careers. None of the people I was immediately with wound up being long time or society leaders here. After I left, Henry White, he actually took my seat, literally. Of course, he filled a much bigger seat than I did, I think. But I left in July, and he arrived in August of 1978, and my seat was empty, and he sat in the desk in the seat that I occupied. And Dick Crooks, who's now at the University of Texas, he arrived shortly after that. John Aletti, the president now, she was there after I was there. So there's a good number of society members who have come through the
strong family tree.
Lab.
You mentioned Henry White. He is the winner of the first Alan Bard Award several years back. University of Utah, is that?
Yes.
Yes, where he is at.
He's dean at the University of Utah now.
Quite a contributor to our science and our organization.
very creative person.
And so you became part of this great family tree, and now you were going to move on to industry, I guess in your case, right? Bell Labs was the first step after UTexas?
It was. I was fortunate enough to interview at several places, several universities and a number of companies, and I really wanted to work at Bell Laboratories. There was enough overlap with what I had done in graduate school with the Bell Labs activities that I said if I could work there, that's where I would really like to go. And so I went there as my first choice of places to go, and it was in the same department as Dennis Turner and various other, Uzi Landau, longtime society member here, now at Case Western Reserve, was there. And it was primarily an electrochemistry department where we were to invent new things. And at the time it was the Bell system. Of course it was Ma Bell in 1978. The Western Electric Company was the manufacturing arm of the Bell system. And it was interesting because in a monopoly, you do things which are different than in a private company, because you do things that, remember, the mission of Ma Bell was universal phone service, not necessarily profits first. And so you had a little bit different mission, and within the Western Electric Company, there were enormous opportunities for process improvement and new processes. They had some of the biggest manufacturing plants in the world for electronic devices and electronic components. And so we just kind of had a license to try and make things better. So it was kind of a very inventive type of organization.
Yes, the monopoly, as you point out, this is very enabling for investment in research and development, and so they could allow this great think tank to do its thing. Do you think there's a need for so Bell Labs is no longer here, and some of the other great think tanks, you just don't see this kind of corporate investment anymore. Is there a need for something like it? Is there a void now that's been created out there, and well, maybe it's in electrochemistry, but the scientific disciplines in general?
In a way, I want to say yes, because it was such a terrific place, but in reality, probably not. I think there are think tanks now. There are very creative laboratories now. Some held in privately in industry. Now they don't publish, and they aren't as public as Bell Laboratories was. IBM was also a very open type of environment, so I think IBM and Bell Labs were similar in that regard. They were able to publish and disseminate information freely, not totally freely, but somewhat freely on the outside. But I think in the government labs now, some of the national labs are really terrific, and they have some of these think tank activities. I think a little more has shifted to universities, where industry will fund them in ways. So I think creative people now find places and ways to do a similar thing, not in quite the same way. So while I miss it, and certainly appreciate what was done, I think we do have places where people can go to and do independent research and express their creative, scientific and engineering creativity. And
I don't know what year, I'll ask you, you left Bell Labs for Georgia Tech. And so when did you do that, and what was your takeaway from Bell Laboratories, your biggest takeaway?
I think my biggest takeaway is that you you could create things, you may have big ideas, and you can see them through. And while they provided an infrastructure for doing this, they were able to fund things, and it was really how many things were created, and it was personal initiative which saw them through. Someone got the resources, someone had the ideas, someone made it over the hurdles. So I think it was just the number of examples of successful products and people, projects. Stephen Chu was here yesterday, and he was a Bell Labs product, and he described how he had an idea and was able to sell it to his management and carry it out and win a Nobel Prize. And I think he could have done that in many places, a university, possibly other laboratories. So I think it was just the confidence and the examples of how to get things done that came very clear in Bell Laboratories.
And you went straight to Georgia Tech from there.
I did.
When?
In 1989. So
Okay.
I stayed at Bell Labs for 11 years, but I really wanted to go to a university. I liked teaching. I liked the teaching enterprise. I liked engaging students. And so I turned that down when I went to Bell Labs initially. I was going to go to a university, but then I was able to make it to Bell Labs. So I never forgot that where I actually wanted to end up.
And so the teaching aspect makes it very different, but can you compare, in a way, your research activities between what happened when you left to Georgia Tech, the differences, what the experience was like?
Sure. In a way, being at a university was not totally different research-wise than Bell Laboratories, because I was able to learn enough at Bell Labs in terms of electrochemistry projects and electronic products that it was easy to carry on. Those were such good topics for research and development that it was easy to transition to a university and just generate more projects in either electrochemistry or electronic materials. And in a way, you become a small business at a university. You have to come up with ideas, you have to sell them, you have to recruit the people, write the reports, and keep this going. And it was somewhat like a Bell Labs experience, how you came up with ideas and you had to sell them. The difference being, though, that you had this enormously energetic pool of new people every year would come in. And so you got this infusion of interest and excitement. And in particular, I like working with undergraduates when they want to do a research, when they want to get started in a research experience, to give them opportunities. And I've now had some, I think maybe 200 or 250 undergraduates work in a lab part-time. They work with graduate students or postdocs. But to see them come in and have ideas and how they just soak it in is really energizing. And every year it happens again. It renews every fall. It starts over again.
I'd like you to now tell us more specifically about your research interests, the work that you've done, and to also point out something you said earlier, is that when you went to University of Texas, all the excitement around electrochemistry and semiconductor technology, which we consider the two big pieces of this organization, and you're pretty unique in some ways in that you've talked about them both. So we're assuming your research interests cover both areas.
Early on, I started even in high school, I did some science projects, and somehow they were both electrochemistry projects. And I don't know how I found them. I remember I wanted to find a book on projects, you know, for science projects, and I couldn't find one, but maybe someone suggested it. But in high school, I did 2 projects and made it to a competition in them. And one was on corrosion. It happened to be using zinc paints for corrosion inhibitors, which they use on ships and so forth. You know, it prevents corrosion if you get nicks in it. You know, it's a sacrificial type material. And I remember my baseball coach helped me with it. He worked for Hooker Chemical, and he got me some of the things they were working on. And in another project, I did actually pulse plating of copper. I read about it somewhere, and somehow I talked my high school teacher into giving me the chemicals to take home. And somehow I got bottles of concentrated sulfuric acid and managed to walk home with them, and I did these in my basement somehow.
That's not going to happen anytime these days, is it?
and today I kind of, how did I even get this stuff home with bottles of chemicals coming? But anyway, so I had somehow stumbled onto electrochemistry. Things were of you know, interesting. And so Bell Laboratories was kind of the perfect mix of topics for me, because I was very much intrigued with semiconductor devices. At first through photovoltaic devices, then transistors and integrated circuits, and the match with electrochemistry is very good. There's common things with transport and operation of electrochemical and solid-state devices. There is a common materials base in some cases, and common basis for how transport occurs. And at Bell Laboratories, it was a perfect combination, because they would chemically process semiconductors into electronic devices. So you got a strong chemistry and chemical engineering background and need. And it was easy to learn some of the basics of semiconductor devices and integrated circuits. And the connection to the society was so perfect also, because I think IBM and Bell Labs very much influenced the Electrochemical Society in the 1960s.
No question.
There was a need for a good publishing and professional society, and I think the location and the outreach that ECS had at that time made it such a nice combination. So I remember when Bruce Hannay, I guess was vice president of Bell Labs at that time, was president of ECS. And so many Bell Labs and IBM people were ECS people on both solid state and electrochemical topics. And
it
so
was a huge influence, yes. I mean, Hannay, I think, was 78, 79. He was the president, and he was he was a senior guy at Bell Laboratories.
Yeah, I guess he was senior vice president, but I don't remember what he was at that date.
But there were so many more.
Yes,
you know, they made that connection. I look at the influence that it had on me when I came to ECS because of their managerial role. You know, I feel in a not an insignificant way that it was the Bell Labs influence that sort of, you know, developed my understanding of what a professional society should be doing for its constituents. And you said also, you know, in the 60s, it was really a Bell Labs person, is my understanding of it, a fellow by the name of Bob Burns, who made that connection. And really drove it. I was just a highly influential person saying this is, you know, a great home because of what this science represents, and along they came, right to the very top with Bruce Hannay.
Right, and ECS always had an electronics side to it, being the application of electricity to chemical processing, but it also had a electronic side with resistances and dielectric materials. It was right from the very beginning. ECS
right.
had a dielectrics type division to it.
Right, yeah, they're very old, you're right, divisions in the ECS long before the 60s.
Yeah.
Well, your work, specifically.
Well, so I found the electronics industry just enormously interesting and exciting. You know, the electronics industry is not like any other industry in the history of the world. It has been growing at a rate that no other industry can, and we've all enjoyed this through our lifetime, how electronic products keep getting better and better every year. And it's not because of optimization or product refinement like you would have in other industries, automobiles or something. It's because of this shrinking of transistors. And if you make them smaller, they will become faster. So we get faster computers and faster phones. They become less expensive, which is why every year our electronic products either get better or faster or less expensive. And it's all due to chemistry and chemical engineering and mechanical engineering. That is, the processes used to make transistors and the interconnect ever smaller. But it requires constant innovation, because you have to have new chemicals for making smaller patterns. You have to have new materials, dielectrics and metals, to interconnect those transistors.
Paul, can I ask, are you describing Moore's law in this?
So this is the basis of Moore's law, yes. And Gordon Moore, at the very beginning, connected these 5 dots or so, where he saw that on an integrated circuit, with time, you would want to put more transistors. And he connected those and characterized the slope of that, how many more transistors per year would go on to an integrated circuit. And it's now called Moore's law, of course. But it really originates from the fact that if the transistor gets smaller, it gets better in virtually every aspect. And no other device does that. Cars get better in some ways if you make them smaller. They get better gas mileage, but they can't carry as much. But a transistor gets better in every way. And I think it's the only device which does that. And that's what Moore's law really is. Transistors get better if you make them smaller. So you have this constant need for better transistors themselves and better interconnect. An interconnect is just the wiring which connects the transistors. And that's now made through electrodeposition, an electrochemical process, in a very creative way, though. It's a very inventive aspect of electrodeposition which allows them to make this copper interconnect in IBM Discovery again. And so the connection between electrochemistry and semiconductor products is very close in some cases. In other cases, it's a little bit removed, but I found both these topics to be enormously interesting and inventive. And so I've been able to contribute in some ways to better interconnect for integrated circuits. That is, electrons have to communicate from transistor to transistor. Transistors are simply switches for electricity. But you make an integrated circuit by connecting them together. So the problem with interconnect is that it does not get better when transistors get smaller. In fact, it gets worse because wires become more resistive. And so there's been a big struggle for the interconnect, or the rest of the electronic device, to get better as the transistors get better. And this continues today. It's a very important topic today, and much of the research going into integrated circuits goes into the rest of the system, how to connect the transistors together, how to connect one integrated circuit to another.
And your work is simply trying to stay on that line that Moore put on a graph and said we can do it smaller and better and faster.
Exactly, but for things other than transistors, it's had to occur through new materials and in not such a straightforward way as just shrinking something. You actually have to introduce newer and lower cost, because Moore's law requires everything gets lower cost, including things that didn't necessarily want to become lower cost. And so it's been really a worldwide effort, and the semiconductor industry is organized in a little different way than other industries, where they have these roadmaps, for example, and Semitech was created.
Right.
So it's in a way more open so that more people can contribute research and development, materials, equipment, and so forth.
Which is a good segue, open, right? Well, first of all, you know, it's not hard to see the importance of this type of work. And so, so now we're going to put the president's hat on you, 2014. And we, as the professional society in this space, right, are looking at ways to make this information more open so we can do exactly as you described, advance it by sharing it. And so we have this, this initiative we call Free the Science, which is really, its essence is just, you know, create a vehicle to just disseminate the information much more broadly as to the communities that are working in the areas that we touch all over the world. And so you were now in the presidency when we said we're gonna do this. In 2014 we started. So why don't you share you know that experience and then some and beyond.
Well, I remember these conversations go back well before 2014, with particularly between headquarters, you and others there, and me and other people, on how what the future holds, and how can we better disseminate. And I think the reason why people should support professional society publications is because, as I mentioned before, I think they are the best stewards of science and technology, of the literature, because at their heart, they have the right motives and the right people working on it, that is the scientists and engineers themselves. And we started this conversation, I think, very early on, at least the seeds of it, when we were doing the electronic publishing, and how we tried to keep prices of the journal low so that as many libraries as possible could receive it. You know, our motive wasn't profit. Our motive was to get as many readers as possible. And then in 2014, I think, the board voted to take on this initiative of open access. And it's such a win for everyone if this can actually be done, because from the author's point of view, me and others, we publish to get people to read this stuff, and to have it held by behind a paywall somewhere, and when someone clicks on your article, the fact that they are then asked to pay some amount of money to see it, or they got to go through a library or something. You know, I wrote the article for free, you know, well, someone paid my salary, but I wrote it to the publisher for free. I gave it to them for free.
Publisher gets a free raw material, that's right.
Free raw material to the publisher. And I want as many people to read it who would like to read it as possible. I don't want them behind a paywall. And from the reader's point of view, being a student or a professional, and just being able to get publications, the ones you want, is so powerful that I was very glad and somewhat surprised that the board could take such a bold move and I was at that board meeting at the time, and I don't know who made the motion. I may have made that final motion at that.
You probably would have had to have done that.
Yeah, I think there was, and there was a short discussion, but there was really no objection and no pushback. It was really a very strong vote of support and great enthusiasm for it.
Right.
And I still think it's a win-win for everybody who, authors, readers, society in general. The more this can be disseminated, especially the research was done with public money, and now to have a for-profit barrier put in, I think is objectionable. And I think someday it'll turn slowly. It'll turn slowly, but the system we have now, it makes it difficult for it to turn.
And I want to comment too. You know, you having been an editor of the journal is, you know, you mentioned, I think a critical point is our editorial board and their role, because it's definitely connected also to our stewardship. It's not just, you know, what we do with the information, you know, in terms of sharing it. It's about the type of information we're sharing, and so the editorial board is one of the enabling pieces we have, because the strength of our editorial board from your days to our current is one of the keys to our success. The dedication of these people, and you know, I have to say, you know, you hate to introduce the money part, but the cost of it. These people are still basically volunteers to us. And you know, small stipends, but it's almost irrelevant, and that's not the way the system works in the commercial world of publishing. So we, because of who we are and because of the commitment people have to both the science and the organization, you know, we have this strength that represents one of the foundations, one of the pillars of our being able to do this. It's a role that, you know, you played a long time ago, but still exists, and I believe is very enabling for us to accomplish this. We couldn't do it without. And so maybe this is a tough question to wrap up with, but to ask you what your thoughts about where you think this is really going to go with, will ECS be able to accomplish this? Will scientific publishing change? Any final thoughts about, you know, your thinking, maybe not that far down the road, 5, 10 years down the road?
Well, I think it's going to change, and I think in order to change it, you need to better couple the author to the price barrier. Right now, an author doesn't really see the price barrier. You know, a library is who buys the subscription. I don't pay money to a library, so I really there's a disconnect between the source of the information and where the money comes from to pay commercial publishers. And so until you get the authors involved in actually paying for this, the true cost of it, and you can couple them better, it's going to be difficult. But one of the places it may change first is in textbook publishing. And that's because the person who pays the money is the recipient. They actually, you know, students actually buy books. And commercial publishing in textbooks, I think, is just as bad as in journals. They are extraordinarily expensive, you know, hundreds of dollars, edition after edition after edition of the same book, simply to get the renewed purchasing of books. You can't use old ones. So the newer students don't do this. You know, there is this revolution going on in electronic textbooks and how students are dealing with this high cost of textbooks. And they're forcing change, I think. So the change may first come from the people who are more linked to it, the students, and they're so savvy in how they buy things now, through internet purchases and so forth, and how they interact, that they just naturally try and fix this problem. So I hope this thing does turn now, as if we can possibly get the true cost pushed back to the author himself or herself. I think doing that will cause a change, and I hope that happens, because I think we would all be better off. The funding agencies, readers, and authors would all be better off with a freer environment. And I sure hope in ECS we can find a way to accomplish our goal, making this open access so we can offer this to all universities, you know, and industrial labs and other people, but we're mostly talking about universities and industry who would read the Journal of the Electrochemical Society and other publications in ECS. And how much better we would be in third world countries if you could give this to their libraries. And so I hope this all happens, and I'm really cheering it on, and I hope I can play a role in this in some way in the continuing future.
Well, you have, and I know that you still do. Paul, thanks for sharing your story today, and thanks for all those years in the trenches with me. You've been a great friend.
Yeah, thank you, Rocky, and I do want to take just a minute to say what a tremendous asset you have been to society. You've been extraordinarily encouraging, supportive. You've had your heart in the right place in a way that I don't know of anyone comparable to you in this society or even other societies that has been so dedicated and done so much. And on behalf of everyone in the society, I want to say personally thank you to you for your dedication, and wish you the best.
Well, thank you very much, Paul.